Today I want to move into, whereas yesterday we kind of found that vertex and then we picked points on either side. Today I really want to talk to you more about transforming the parent functions rather than picking all these random points and plugging in. It's a little more sophisticated way. I'm so happy to hear that you guys have already done transformations before. Some of us have done transformations. So maybe we'll ease into it a little bit more. I also would really, really, really like to at least give you your project. I might wait till tomorrow. I'll see how overwhelmed you feel by the end of this class. But we will spend most of, unless you are an over-the-top person, you'll be able to do your project in class. We'll take a few days of work days in class, tomorrow being one of them, and probably Tuesday as well. So maybe it'll be due next Wednesday. We'll see. I'll let you know. But it'll be a major grade, and this is also the last of the unit, believe it or not. This is a pretty short little unit. I haven't even, I never even finished assigning the content. I put like 6, I started it and I was it. Like in total, like y'all had 60 last time, there's like 6. Right now, yeah. Several of y'all struggled with the Khan Academy last time. But I was really looking at the correlation between the Khan Academy and the grades. If you finished all your Khan Academy, your test grade was generally pretty good. So I think there is some correlation there. But I think it was a little overkill with the amount that was on it. So I'm going to look. I'll look and let y'all know what we're going to do. But for this unit, we're probably going to hold off for a little while in Khan Academy. Maybe pick it up back up next unit. What is this, 3? It's only, oh yeah, that is right. Functions, do y'all know what parent functions are? Alright, so this will be parent functions and transformations today. So before I tell you about transformations, I first need to tell you about parent functions because we do transformations on the parent functions itself. So parent functions are just our most basic functions that we have. No transformations have been done, and you are going to be focusing mainly on 3 parent functions. We will be adding to these parent functions as we go, but right now I want you focused on 3. Those 3 are linear, which is just the graph y equals x. What does that look like when you graph it? What kind of line? Not that. Not that. There you go. It just looks like that. So that is the parent graph for all linear functions. And from there, we can start sliding, shifting, shrinking, stretching, and we'll talk about all that good stuff. The second one, okay, tell me when you're with me. No, it's okay. I apologize. The second one is quadratic. What do you think the parent graph equation-wise looks like for quadratics? Close. It's just x squared. Not down, though. Yeah, right. So it's just a parabola centered at 0, so it just looks like that's what the parent graph looks like. Everybody okay? No? What's wrong? What do you think the third one is? I told you 3. What parent? What's the third parent, the family, function family, you think? Well, these are all parents. These are all parent functions. This is parent function 1, parent. There's going to be 3 we focus on. That's a good guess, but you were. That's okay. What did we do yesterday? Absolute value. And so the parent equation is just y equals absolute value of x. And what does that look like? That's right. It comes down to a sharp point like this. When you start talking about transformations in geometry, what's a translation? But what is that? What's that? Like you've got translations, reflections, dilations, rotations. Okay, that's a reflection. What's a translation? You're right. It's just a slide over, right? You just move it. That's exactly what I'm doing. I call them slides. I don't know what your teacher called them. I call them slides. You just slide it over. The shape doesn't change. It doesn't flip. It doesn't stretch. It doesn't shrink. It doesn't do any of that. It just simply slides, okay? So I can slide left and right or up and down. I'm not going diagonally. I'm up and down or left and right, okay? And to do that, if you look, we'll talk about vertical translations first. These are the first two lines on your pink sheet. And that pink sheet might be a little intimidating at first, but you'll see it's really not that bad. So sometimes I'll let you use it as we go. We'll see. All right, so here's what happens. You have a vertical translation. All that means is, and this, I'm just using f of x to say my entire equation, okay? If I add a number to the end, any number at all, that moves my graph up c units. And if I subtract some number on the end, and if this doesn't make sense, I'm going to show you an example and hopefully it will. That means I move down c units. So I think this is easier to see in an example. Let me show you what I'm talking about. So if I take that parent graph, let's say the absolute value, since that's what we were working on before, right? That parent graph goes 0, 0, 1, 1, negative 1, 1, right? Everybody agree? Say yes, because that's right. Okay. If I took that same graph and I said, okay, then what would absolute value of x plus 2 look like? That means I take every single point, that's exactly right, and they go up 2, up 2, up 2, up 2. Yep, every point on the graph. And so if you look at your pink sheet, it says, there's that last column that says change. Some students like that column and some don't. It says XY. That means what you started with on the green one, right? Changes to, you keep your X the same, and for every Y, you add the C to it. So in other words, this point was 0, 0. So I started with 0, 0. My new point after I do this is going to be 0. What was my C? Look in that blue equation. 2. So that point becomes 0, 2, 0, 2. It's just showing you how to actually algebraically find the points rather than just sliding them. Yeah. How many of you have seen this before? Raise your hand. Okay. This up and down, left and right. Left and right's a little bit harder, but up and down is easy. Yeah, let's start it easier. Oh, really? All right. Y'all good? Okay. Well, I'm glad that I've actually. I can't believe you did that, right? Because I can't figure out how he would, how that would have ever helped, like what he did. It looks like he literally, it looks like he got bored and just wrote down the same thing on the desk. Like I can't figure it out. Tell me what's going on. What does that mean? A parabola -1. It goes down 1. So this is the parent, which is the quadratic, and it just shifts down 1. So the parent, again, quadratics and absolute values look a lot alike, right? Except the quadratic kind of smooths out and goes up that way, and the absolute value is linear. But here, I just take the same one, and every point goes down 1. Every point down 1. Every point down 1. So there's what I look like once I have shifted down. Mm-hmm. Everything. Every single point down 1. Go okay on vertical? Dilation. I know it's hard. That gets hard. All right, y'all ready for the next one? We might hang out at translations and reflections today. What? Yeah. We're still doing translations. We're gonna do. Now we're gonna do horizontal translations. Now, horizontal has to do with the x-axis, and anything to do with the x-axis is always opposite. It gets so stinking confusing, I know. But here, if you look at your little cheat sheet, now we're on lines 3 and 4. Notice how this value is hooked to the x. Okay, that's going to be your key, is that it's hooked to the x. If I'm added to the x, that means that I actually move left. It would seem that you move right because you're adding, but what I actually do is move left. And if I subtract, then that means that I move right. Go with me? Sorry. No. No, because you're not. All right, let me show you. What's the parent graph? Absolute value. What is being done to the parent graph here? I've moved it right 3. Okay. No, because so this is going right 3. So if I think about the parent, right? Here's the parent. Every single point on my graph moves to the right 3. 1, 2, 3. 1, 2, 3. 1, 2. Does that make sense? What's the domain of my new function? What's the range? Oh, I thought I was going to get y'all. All right, let's see if you got it. Yeah. Describe the transformation. How do you know it's going up 5 and that it's not horizontal? There's no parentheses. That's exactly right. Good job. This one's up 5, and I say this because this is where everybody gets mixed up. Whereas this one is going left 5. Do you see the difference? The parentheses make it hook to the X that way. So good? All right, let's talk about reflections. Can you have multiple transformations, by the way? Sure. Have you ever seen an equation that looks like this? You saw it yesterday. That's exactly right. So instead of thinking about it being a vertex, which it still is, tell me the transformations that happen here. It goes left 1 and down 3. You see why that's the vertex now? If I started, my parent starts here, but every point needs to go left 1, down 3. Left 1, down 3. Left 1, down 3. Reflections. Do you remember how things reflect? If you got to flip signs, right? So what I'm mainly going to be talking about with the reflections is either reflecting over the x-axis or reflecting over the y-axis. So if that axis were a mirror. Why can't I say mirror? Golly. Then what that would look like on the other side, right? So most of these, if I reflect over the y-axis, they're going to look exactly the same, right? For my quadratic and my absolute value anyway. But if I reflect over x, then what does that look like? If I took a quadratic like this and I reflected it over the x-axis, what does it look like? It just flips it upside down, right? Right. So this is that, remember when the A was in front, if it was negative, it went down, if it was positive, that's y. So if I reflect over x, then I just put a negative in front of the whole equation and it reflects over x. But if I ever want to reflect over y, then I have to put a negative on each x in the equation and it will reflect over y. These are pretty easy. These are pretty easy. If you look at the column that says change, if I reflect over x, then I take every point that was on there, I keep the x the same, but I change the y. I make the y opposite. So it's different than what you think because I'm reflecting over x, but I'm negating y. And then vice versa if I reflect over the y-axis. I'm negating x. All right. I've given you some equations. I've asked you what they do. Now let me give you a graph and see if you can tell me what's happening. Can you what? I can't tell you. Yeah, I'm going to stop with reflection. Yeah. I actually have you a transformation packet that we're going to do part of today and part of tomorrow. Give me the parent. This one. Which one is, what is this? The absolute. Parent, this is what your homework will look like. Parent. Tell me the transformations that are happening. Oh, wait. From the parent, what are the transformations that are occurring on this graph? All right, we know that it moved to the right. How many? And it went down 1. And it was reflected in what? Reflected over X or Y? X. Because it's upside down. So this is my x-axis. So if that was the mirror, then it just flipped over. Okay. Now let's see. Tell me what the equation would be for my new graph. X minus 1 in the absolute value, minus 1 on the end. How do I reflect it? Okay, so where does the negative go? Well, but don't do it in the F, do it over here in the equation. I probably should have showed you that. It is, so this means just take whatever your equation is and put it in the front. So this is reflected over, put this in your notes with reflection. And this is reflect over Y. Does that make sense? Sorry, I didn't explain that very well. All right. What's the vertex? You see how it's written that way, and that's the way we were graphing yesterday, but today we're using transformations to do it. What's the domain? What's the range? The range is negative infinity to negative 1. That's exactly right. Do you think you can do these? No? Okay, which part don't you understand? For the ones we're just working with those 3 parents, but mostly not even the linear. We're just looking at the absolute value and the quadratic.